So let's continue with another problem. L inverse of s by s square plus a square. So here also I should write it as L inverse of f bar of s dot g bar of s. So f bar of s is one term I have to take as a standard term. So I will take as 1 divided by s square plus a square because I have whole square, and g bar of s I will combine it with s. So s divided by s square plus a square whole square. So you can find out f of t. It is standard, so you know that sin at by a. I should apply L on both sides, so L of this will give you this. Similarly, I can get g of t. This is not square, so it is cos at. I will write f of u, which is sin au by a. I will write g of t minus u, which is cos of at minus au. So you know convolution theorem gives you L inverse of f bar of s into g bar of s is integral u varies from 0 to t f of u into g of t minus u du. So which gives you integral u varies from 0 to t f of u is nothing but this term sin au 1 by a outside into g of t minus u cos of at minus au du. So basically you can't integrate this directly because you have product of two sine terms. So this au can be treated as capital A and this whole term can be treated as capital B. So it is sin A cos B. You know sin A cos B is half of sin of a plus b plus sin of a minus b. So using that result we end up with 1 by 2a outside integral u varies from 0 to t sin at plus sin of 2au minus at du. So you should use the sin of a plus b plus sin of a minus b result, and if you integrate you end up with so sin at into du, because at is nothing, because you are doing with du, sin at is constant, so you get sin at into u 0 to t plus this term is cos of 2au minus at whole divided by 2a, and this is minus because integration of sin is minus cos, and it will take the limit 0 to t. So you end up with t sin at by 2a. If you apply the limit 2 sin at into t sin at, and this term will be 0 because of course you have 1 by 2a outside for whole term, and if you apply t upper limit 2at minus at cos at, and it is 1 minus cos at, so it is cos at minus cos at will be 0, so you end up with this result. So we can continue with another problem. So basically whatever the problem given, you have to separate it as f bar of s and g bar of s, and then you have to apply convolution to find the inverse. So I am taking another problem, that is L inverse of 1 divided by s minus 1 into s square plus 1. So here also my f bar of s is 1 by s minus 1 and g bar of s is 1 by s square plus 1. So from this I can find out f of t, which is e power t, and g of t, which is sin t by 1, which I don't write, 1, and f of u is e power u, and g of t minus u is sine of t minus u. So if I put it in convolution theorem, u varies from 0 to t, e power u into sine of t minus u du. Again you will use the formula e power ax into sine bx. And remember, t is constant, u is the variable. So you will end up with e power u by 1 plus 1 into sine of t minus u plus cos of t minus u. And the whole integral takes the limit u varies from 0 to t. So if you use this and upper limit minus lower limit, you end up with half into e power t minus sin t minus cos t. So basically whatever the problem given, you have to separate it as f bar of s and g bar of s as standard ILTs, and find f of t and g of t by applying L on both sides. Then replace t by u, t by g, g of t by t minus u, put it in the integral, but remember integral is with respect to u only, and at last you will integrate and put the answer in terms of t.